Thank you for listening. This course was created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional podcasts, books, newsletters, and cool merchandise await. Let's get started. Enterprise architecture is the structured design of your organization's information systems, the blueprint that maps business processes to technology capabilities so teams build in a coherent, intentional way. At its best, it aligns strategy with execution. The outcomes the business cares about flow into standards for identity, data, integration, and runtime platforms. Extending this mindset to artificial intelligence means treating models, prompts, datasets, agents, and evaluation pipelines as first-class architectural elements, not experiments on the side. You define their trust boundaries, life cycles, and dependencies the same way you would for payments, identity, or messaging. The payoff is predictability under pressure. When security or compliance needs tighten, you already know where to adjust policies, which telemetry to inspect, and how to roll back safely. Enterprise architecture, in short, turns AI from bespoke projects into a managed system that can scale without multiplying risk. Patterns are the vocabulary of architecture reusable design solutions that encode what works and what to avoid. A pattern names a problem, describes the forces at play, and presents a proven arrangement of components, policies, and flows. By standardizing on patterns, you reduce ad hoc builds that drift in style, quality, and risk, and you make cross-team collaboration easier because everyone shares expectations. Consistency is not about sameness for its own sake. It is about making good decisions repeatable. When security patterns become defaults in templates and platforms, busy engineers inherit guardrails without rereading policy. Reviews speed up because patterns come with pre-approved controls, evidence hooks, and escalation paths. And when an incident happens, responders already understand the terrain. The same pattern is deployed in many places, so one fix or detection improvement scales across the fleet. Zero Trust architecture applies a simple idea relentlessly. Never assume trust based on network location or prior success. Verify each access with context. Practically, that means identity-first enforcement at every boundary. Users, services, agents, and automated jobs must authenticate and authorize for the exact action they seek. Segmentation breaks environments into small, purpose-tied zones so compromise cannot roam. Adaptive authentication raises or lowers friction based on risk signals like device health, anomaly scores, and data sensitivity. For AI systems, Zero Trust closes gaps where models and agents call tools or fetch data. Tokens are scoped and short-lived. Policies are evaluated per call, and sensitive actions demand step-up verification or human confirmation. The result is a system that treats internal calls like external ones, shrinking implicit trust. It is more work up front, but it pays back in fewer pivots, cleaner forensics, and safer automation. Defense in-depth layers mutually reinforcing controls so a single miss does not become a breach. No detector is perfect and no policy is eternal, so you design overlapping safeguards that fail differently. In AI contexts, that could include content filters at the edge, guardrails in the model, allow lists in the tool layer, and anomaly detection in telemetry pipelines. You backstop runtime with immutable logging, signed models and datasets, and keys stored in hardware modules. Network segmentation and identity checks sit under the application layer, while backup and recovery plans stand ready above it. Redundancy matters too. Multiple signals for the same risk like prompt injection detection plus tool use limits. Catch what the other misses. Defense in depth is not about stacking everything. It is about layering thoughtfully so each control covers a neighbor's blind spot without crushing performance or developer velocity. A data-centric security pattern starts from the premise that data, not servers, is the crown jewel. Controls travel with the asset, encryption and tokenization by default, field-level masking in lower environments, and granular attribute-based access policies that consider purpose, role, and sensitivity. Provenance tracking records where data came from and how it changed, so you can audit training corpora and feature stores. Lifecycle coverage ensures data is governed from collection through labeling, training, inference, retention, and deletion, with deletion proved, not assumed. For AI, a data-centric pattern reduces both privacy risk and model toxicity. You keep sensitive attributes out of contexts that do not need them, and you can unwind contamination because you know which datasets and checkpoints were involved. When data rules are consistent across platforms, teams stop reinventing controls and start composing them. A cloud-native AI security pattern accepts containers, serverless functions, and managed services as the substrate and hardens around that reality. Containerized inference isolates runtime per model or tenant, with minimal base images, read-only file systems, and strict inter-service policies. Serverless isolation shrinks attack surface by eliminating long-lived servers and scales by design during spikes. API gateways centralize authentication, authorization, quota, and schema validation for model endpoints, reducing bespoke glue code. Continuous observability structured logs, traces, metrics, and model-specific telemetry feeds detection and capacity planning. Golden images and infrastructure as code make environments reproducible. Signed artifacts and admission controls block drift. This pattern does not assume cloud providers are perfect. It assumes they are programmable. You use their controls with discipline, measure coverage, and design for portability so the same guardrails follow workloads across regions and vendors. Federated learning addresses a central tension. You want models that benefit from many datasets, but you cannot ship those datasets to a central pool. Instead, training happens where data lives on devices, hospitals, branches, and only model updates travel. Secure aggregation protocols combine those updates so the server cannot inspect any single participant's contribution, and differential privacy adds noise that limits what can be inferred about individuals. Because data never leaves its enclave, local privacy and regulatory boundaries are easier to respect, while bandwidth needs shrink. Robust aggregation, using medians, outlier pruning, or reputation weighting adds resilience against poisoned updates. This pattern is not magic. Heterogeneity, intermittent connectivity, and stragglers complicate scheduling and evaluation. Yet when sensitive data and distributed control dominate your landscape, federated learning offers a principled path to learn from many without centralizing what must remain local. A secure agent pattern treats tool-using models as programmable employees with narrow, auditable jobs. Start with scoped permissions. Each agent receives the least authority needed, time-boxed and purpose-bound, expressed as fine-grained roles rather than broad tokens. Sandboxed execution limits file system, network egress, and process privileges, so mistakes and compromises stay contained. Validated tool calls run through typed contracts and policy checks required arguments, allowed domains, rate limits, and human approvals for irreversible actions. Orchestration is continuously monitored. Every prompt, decision, tool invocation, and observation lands in structured logs with correlation IDs for replay. Add guardrails like dry run modes, kill switches, and escalation to human supervisors on anomaly. The result is autonomy with seatbelts. Agents can move quickly inside safe lanes, while violations are prevented or surfaced early enough to intervene without drama. A provenance and watermarking pattern embeds authenticity into the artifact itself and the process around it. Generation pipelines attach cryptographically signed manifests that record origin, time, and edit steps, creating a verifiable lineage that resists quiet revision. Where appropriate, generators also embed imperceptible watermarks, so downstream services can flag machine-produced outputs even after common transformations. Verification is one click in publishing tools and one policy in ingestion gateways. Trust increases when signatures validate and marks align with claims. Scrutiny rises when they do not. This pattern links directly to compliance obligations for labeling synthetic media and preserving edit history, while giving users understandable cues about what they are seeing. It will not stop hostile fabrications entirely, but it shortens debate about origin and enables consistent, auditable handling across products and partners. Monitoring and observability convert running systems into readable stories, Telemetry pipelines collect prompts, outputs, tool calls, latencies, error codes, and model-specific signals like refusal rates, toxicity scores, and embedding drift. Stream processors and anomaly detectors turn those streams into alerts and context, while dashboards show health by service, model version, and tenant. Integration with your security information and event management platform correlates AI signals with identity, endpoint, and network data, closing blind spots that appear when systems are viewed in isolation. For executives and boards, concise roll-ups track incidents, detection latency, coverage of guardrails, and trends in risky behavior. Observability is not ornament, it is the difference between guessing and knowing. When facts are visible, you can tune thresholds, target training, and justify investments with evidence rather than intuition. A governance-driven pattern encodes policy as part of the architecture rather than as a separate binder. Admission controllers reject unsigned models, missing manifests, or unapproved data sources. Pipelines enforce privacy and licensing checks before training, require evaluation and red team sign-offs before deployment, and checkpoint artifacts for reproducibility. Escalation channels are defined in the system. Certain severities open cases, page owners, and trigger pre-written communications. Designs are audit-ready by construction, with machine-readable mappings to frameworks so evidence collection is exportable. Exceptions exist but are time-limited, owner-assigned, and reported upward until closed. The effect is cultural and technical. Teams experience compliance as clear gates and fast feedback, while leaders see a living control system that adapts with the business instead of slowing it. Integrating patterns means composing them thoughtfully, rather than stacking everything everywhere. Zero Trust wraps agent and API interactions. Defense in depth places complementary controls at edge, model, and tool layers. Data-centric rules govern what flows through all of it. Provenance and watermarking ride generation paths, while observability stitches outcomes into a shared view. Enterprise-wide templates capture these combinations as modular blueprints engineers can instantiate with minimal choice, and platform teams supply paved roads that embed defaults. Trade-offs are explicit. Where latency is critical, choose lighter guards with stronger monitoring. Where impact is high, prefer stricter gates and manual confirmations. The aim is consistency without rigidity patterns that fit together cleanly, evolve independently, and scale across varied teams and use cases. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Scaling across an enterprise is less about a single blueprint and more about a repeatable way to spread good defaults. Start with distributed adoption. Platform teams publish paved roads that package patterns as code, templates, and guardrail policies, while product teams adopt them with light customization. Federated governance keeps momentum by delegating routine approvals to domain stewards under a shared standard, reserving central review for high-risk deviations. Automation of enforcement turns guidelines into admission controls, CI checks, and policy as code, so drift is caught where it starts, at merge, deploy, or runtime. Continuous evaluation closes the loop with scorecards that show coverage, exceptions, and outcomes by unit. Think of it like franchising. You scale the brand by scaling the recipe, ingredients, and inspections, not by micromanaging every kitchen. Metrics translate architectural intent into signals leaders can act on. Incident reduction trends show whether standardized patterns meaningfully lower escape paths, especially for recurring classes like overprivileged agents or misrouted data. Compliance coverage scores quantify how many services ship with required controls, signed artifacts, provenance manifests, least privilege scopes, so audits become verification, not discovery. Detection latency tracks time from anomaly to alert across layers, edge filters, model guardrails, tool gateways, revealing where observability is thin. Resource efficiency ensures security doesn't silently tax velocity. Measure cost per million tokens, cold start impact from isolation, and cache hit rates after segmentation. present metrics per business line and risk tier, and tie them to incentives funding for teams that close gaps, and stricter gates where trends stagnate. A dashboard that changes budgets is a dashboard that matters. Patterns also carry pitfalls. Overstandardization can smother valid innovation. The cure is a clearly defined escape hatch with evidence and time limits, not a permanent fork. Legacy integration is thorny. Monoliths and flat networks resist zero trust or data-centric controls, so plan staged refactors, compensating controls, and choke point enforcement while you pay down debt. Adversaries evolve, turning static pattern checklists into drift. Schedule periodic threat-led reviews that refresh defaults and test assumptions with red teams. Performance trade-offs are real sandboxing, signing, and provenance checks, add latency and cost to, profile hot paths, cache decisions, and reserve heavy checks for high-impact flows. Patterns should be living agreements between security and delivery, not stone tablets. When they hurt outcomes, fix the design rather than waiving the control. The benefits, when patterns fit the work, are compounding. Predictable resilience emerges because failure modes look familiar and fixes scale. One improvement to an agent sandbox or API gateway helps dozens of teams overnight. Audits become easier as evidence is built in signed models, lineage manifests, and standardized logs mean show me takes minutes, not weeks. Misconfiguration shrinks when developers assemble from secure modules rather than wiring controls by hand. Design cycles accelerate because reviews focus on deltas to the pattern, not first principles. Most importantly, reliability becomes cultural. Engineers learn to reach for the paved road because it ships faster and breaks less, while leadership sees risk curves bend down without endless meetings. A good pattern is a quiet teacher. It nudges everyone towards safer, sharper work. Sector applications reveal how the same patterns flex to local constraints. In finance, zero trust and data-centric controls guard payments and trading, with step-up verification for agent tool calls and immutable logs to satisfy surveillance rules. Healthcare leans on privacy by default and provenance to protect clinical data, pairing federated learning with strict evaluation before decision support reaches clinicians. Education benefits from observability-first designs that surface bias and drift while honoring minors, data protections, and parental rights. Government programs skew compliance-driven. Admission controls tied to approved datasets, impact assessments baked into pipelines, and public-facing provenance for official media. The architecture vocabulary stays consistent: identity, segmentation, provenance, observability, while the weighting changes by mission, risk, and law. Strategically, patterns embed security into enterprise DNA. They let you scale AI safely by turning good practice into infrastructure, identity-first gates, layered guardrails, portable artifacts, and visible lineage. Systemic risk drops because shared weaknesses are retired once, not rediscovered in every team. Regulatory alignment stops being a sprint before audits and becomes a property of how you build. Policies compile into code. Code compiles into controls. Controls compile into evidence. This is the quiet power of architectureless heroism, more habit. When patterns are the path of least resistance, your organization moves faster, precisely because it moves more safely, and your credibility with customers, partners, and regulators grows with every uneventful release. Architecture patterns pay off when you can see the through line across everything you build. You now have a language for that through line: identity-first access at every boundary, layered controls that fail differently, data rules that travel with the asset, provenance that turns trust into verification, and observability that makes behavior legible. The purpose is not to chase novelty but to eliminate accidental design, so risks become choices you make consciously and can explain later. When patterns are embodied in platforms and templates, teams start from a higher floor. Common mistakes are simply harder to make, and incident responders debug familiar shapes instead of archaeological curiosities. Think of the enterprise not as one big system, but as a population of consistent small systems. Patterns are how you keep the population healthy, even as individual services change, scale, and retire over time. Among the many patterns we introduced, 3 deserve special emphasis because they bend risk curves the most. Zero Trust removes the dangerous fiction of inside by forcing every call user, service, or agent to prove who it is and what it may do right now for this action. Defense in Depth acknowledges the detection and policy will sometimes miss, so it layers controls that cover one another's blind spots and fail in different ways. Data-centric security recognizes that breaches are about information, not boxes, and therefore encrypts, masks, and labels by default while tracking lineage through training and inference. When these 3 become unconscious defaults, the rest of your program becomes easier. Provenance has a home, observability has useful signals, and recovery paths are known before anything goes wrong. Benefits and limits travel together, and you should expect both. Patterns accelerate design reviews, reduce misconfiguration, harden common failure modes, and turn audits into verification rather than scavenger hunts. They also introduce friction when applied without nuance. Sandboxing can add latency, provenance checks can tax pipelines, and strict segmentation can complicate legacy integrations. Overstandardization can smother valid experiments, while understandardization invites drift back toward bespoke systems. The way through is to treat patterns as living agreements with clear escape valves. Require evidence for deviations, time box exceptions, and schedule threat-led refreshes that revise defaults when adversaries or workloads change. In short, defend the core, tune at the edges, and keep the revision loop short enough that patterns evolve faster than your backlog of workarounds. If you were to start Monday, begin by choosing 1 or 2 high-impact patterns to pave, rather than attempting everything at once. Wrap them in code, reference architectures, policy bundles, admission controls, and CI checks that teams adopt by creating a project, not by reading a binder. Publish what good looks like in the same developer portals where engineers already live, and make early adopters visible so momentum compounds. Add a small scorecard coverage of signed artifacts, least privileged scopes, and observability baselines, and make it part of sprint rituals so progress is routine, not executive theater. Pair the rollouts with office hours and lightweight training that show how the paved road removes toil. The signal you want engineers to internalize is simple. The fastest path to shipping is also the safest path to operate. Sustaining momentum is a leadership and culture project. Patterns must be taught, not merely announced, through design reviews that coach teams toward better choices and post-incident write-ups that feed improvements back into templates. Explain the why behind guardrails so teams can extend them correctly when the pattern does not quite fit. Keep a visible backlog of pattern enhancements and retirements, and celebrate removals as much as additions. Pruning is how systems stay nimble. Align incentives by tying budget and roadmap approvals to pattern adoption, and by rewarding teams that reduce exceptions over time. Most of all, keep the conversation threat-led. When updates are grounded in fresh adversary behaviors and real incidents, patterns feel like living defenses rather than compliance furniture. Stepping back, enterprise architecture patterns are how you embed security into organizational DNA. We defined a shared vocabulary, explored designs that travel well, from zero trust and defense in depth to data-centric controls, provenance, and observability, and showed how to scale them with paved roads, federated governance, and metrics that change decisions. We also confronted limits and trade-offs so your program stays practical. With the technical scaffolding in place, our next focus turns to people and process, the operating model that assigns roles, sharpens skills, and runs the cadences that keep patterns alive in daily work. Security becomes real when humans can execute it under pressure. That is where we go next. How to organize, train, and lead so the architecture you've designed performs as intended when it matters. Thanks for tuning in to Bare Metal Cyber, your trusted source for cybersecurity educational materials, news, and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.